and GitHub where I keep my code. On the right-hand side over here, I've got Ubuntu. This is running under WSL, and if I go and run lsb_release-a, you can see that this is in fact Ubuntu 2004, and I've gone so far as to put the graphics in the corner. Thank you for the friends at PowerShell Magazine for letting me use that graphic. That way I can keep track of these things, and if I pull down this top menu here, you can see I'm using PowerShell as my default prompt. That is actually PowerShell 7.2. PowerShell 7.2, in fact, came out just yesterday, in fact, using .NET 6. Predictive pop-down history there. Details about that are on my blog. And you'll see that it popped up a couple of URLs here. We've got localhost 5000 HTTP, HTTPS, the secure one is 5001. You'll notice that if I hover over those, because I'm using Windows Terminal, I can go and click on that and it'll actually bring up the browser for me. And then there's my personal website that happens to be running on localhost. Now that's localhost 5001 running on Windows, which is cool. I'll hit Control-C. We're going to come over here. I'm going to click on Ubuntu. I'm going to hold down Alt with my left thumb, and that's going to pop open that other pane on the side there. So again, I've got Windows on the left, and I've got Ubuntu on the right. We'll zoom in a little bit, make sure that everyone can see that, and I'll go and open up the Hanselman core. And I'm going to say .NET-info here, and we can see that I've got both the .NET SDKs, .NET 5, and the new LTS, the long-term support version of .NET 6.0 running in this folder right here. So I'll say .NET Run. Certainly I could use Visual Studio Code if I felt like it. And then you can see right there, once again, localhost 5000, localhost 5001. Go and click on those, bring that up, get my website again. Okay, we cleared that HSTS error. That was as local Docker containers, which allows me to do stuff cross-platform. These are really simple little scripts. There's really nothing here. If we go and look at one of them, we'll take a look at Docker build. This one here has what's called a hash bang at the top, and that means that we'll use that particular Linux application when I run that script, but it will be ignored on Windows because it uses a .ps1 extension, which means that I can run this script on Linux or Windows and it works in both places, which is super nice. And that's just going to go and build my podcast with Docker. So I'll go and say Docker build, and we'll do that. And then we'll get some nice ASCII art here as we ran through all of that. It looks like that was previously cached from me building before. We're using Docker Desktop, and Docker is actually using WSL and using Linux as that engine. So underneath that is the Linux subsystem that we have built into Windows. When we went and did that, I can go now and I could say Docker images, and I can see that we've got one tagged podcast. Now we saw earlier with both Scott Hunter and David Fowler, they were talking about the Azure Container Apps stuff, which is pretty cool. I want to go and take those Azure Container Apps and use them, but I wanted to see how quickly and how easily I could put a potential website up into the cloud by just pushing it, right? I have got a Docker thing here, .NET 6 just came out, maybe I can go and do that. So what I can go and end up doing is I can tag with Docker tag. Think about power sipping. I've got a couple other ones here as well. I've got a Raspberry Pi. So I've got a Raspberry Pi 4 right here. Runs a full version of Raspbian. I can run different alternative distros here. Also runs .NET. Works great. In fact, we've got some friends like PyTop that have a Raspberry Pi that actually ships with .NET and with the .NET Interactive Notebook. So that's cool. That's small. That's small. Well, look at this. Just got this today. This is a Raspberry Pi 02. The 02. Little tiny $15 processor. This happens to be an ARM 8 processor. .NET supported on ARM 7 and up, so this little $15 guy right here, he's got HDMI, he's got a little disk there, he's got two USBs, one for power and one for a hub. That runs .NET as well. This is great for IoT projects, which are super cool, but it's worth pointing out that something like this is a microprocessor. This runs a full operating system, and that might be overkill for what you're doing. You know, if I'm just turning lights on and off, a Raspberry Pi is too much. If I'm just doing something small in my garage and I want to make something happen with my my Raspberry Pi, maybe turn on my watering outside, this might be too much. This is a microprocessor. Wouldn't it be cool to do something with a microcontroller? Take a look at this. Our friends at Nano Framework.net have got easy C# code in embedded systems. Again, this is great work that's happening in the community, whether it be open source or small businesses, making it easy to write code for embedded systems. These embedded systems will actually integrate directly with Visual Studio, so you can press F5 and drop into the code on one of these tiny devices. A microcontroller being much smaller and much more single-tasked and much more power efficient than a microprocessor that runs an entire operating system. So kudos to our friends at Nano Framework. Another cool one is Wilderness Labs. Wilderness Labs has this thing here. Wilderness Labs has the Meadow process, the Meadow processor. And the Meadow processor, after a successful Kickstarter, is now a business. And look at this, Wilderness Labs, that is a .NET application. I happen to flash this device, this tiny microcontroller, from WSL. I'm going to have a blog post about this soon, and you can take a look at the WSL blog. WSL now has support for USB over IP so that you can plug a device into Windows. Even if Windows doesn't have drivers for it, we'll be able to talk to it directly from Linux. But of course, our friends at Meadow have great integration with Visual Studio, so I was able to write C#, hit F5, and show this picture of Tux and WSL directly on this device. And the screen is from our friends at Adafruit, and this has all been put together with their system. So kudos to them, both Nano Framework and our friends at Wilderness Labs. That's somewhere you wouldn't expect to see .NET. That Raspberry Pi Zero, pretty cool. You can do cameras, you can do on-chip machine learning. Again, just $15, great little project. We've got system.devices.io, which is really, really cool. We talked about how PowerShell 7.2 is built on .NET 6, and they ship the same day, which is cool. I want to showcase some companies and some other folks that are doing great stuff in the .NET space. Uno platform at platform.uno is really cool. This is a UI platform, again, not associated with Microsoft, just doing great work with the great software stack, the great open source software stack that they were given. They've got a conference coming up soon, UnoConf. These folks have the ability to go and run C# and XAML with WebAssembly, desktop and mobile. And here's a cool example where we've got a calculator, like a Windows calculator running in the browser. Isn't that great? Very, very cool, built with the Uno platform. So, you might see stuff like this. You think about Blazor. There's a lot of cool community folks doing great works with Blazor. Here's a one-man shop, one-person shop, blazor-university.com. Person put together a whole website with an invaluable resource on how to learn Blazor. I love it when I see community folks building software and teaching us how to use our own products. It makes me happy. You can also do a lot of this work in the browser. Blazor not only runs everything in the browser, but when you put the power of the cloud on the back end, you've got folks like our friends at gitpod.io, where I've taken my Hanselman website, and I can go and click on that website, open that up, look at that workspace, and then load it up into an instance of a VS Code-like environment. It pulls that container image down, and I've got the power to develop software in the cloud. That's a company called Gitpod. You might think that that's quite similar to things like code spaces. Very similar concept, this idea of what's the responsibility of the cloud, what is the responsibility of my browser. If you're on a Chromebook or a low-power device, you've got just a browser available to you. Take a look at solutions like this. When I go and start up my code space, you can see here that I've got Visual Studio Code. I'm actually right back where I was editing my website. I can open up that stuff, see it directly here, and even set breakpoints, which is fantastic. And I've got a terminal. You can tell that it's a real terminal because I can run htop, and you see I haven't left my browser, which is really, really cool. We've also got our friends at Progress Telerik that are making some really, really cool stuff, something that they just came out with a couple weeks ago, the REPL, Read, Evaluate, Print Loop. REPLs are real popular for learning things. They have a REPL for Blazor that you can check out. You actually write the code for Blazor in the browser, hit run, they'll compile the assembly, and they'll ship the assembly down in real time. And they've got all kinds of samples, asset managers, and you can build your website inside of here and play with those great controls that our friends at Progress Telerik have. And then a shout out to some smaller folks, because not everyone's got a big $1 million company. We just put out a tweet saying, hey, who would you not expect to see in a .NET Conf keynote or lock note? One-person shop, friends at Turner Software, problem solvers doing cool stuff with .NET. Here's a company, Ironman Software. They do some PowerShell stuff. Website, their flagship product built on .NET. Positiwise, they tweeted me and said that they're doing their work in .NET, front-end and back-end work. Quibu, they're doing work in .NET. Alchemy doing digital banking in .NET. We've got Silver Key Tech, their technology stack, ASP.NET Core. They're using Vue.js. They're using Blazor. Very, very cool stuff. Madcap Software. These are all folks that are having fun and doing cool, productive work in .NET, and that just makes me smile. Here's another great one, another small business, sixlabors.com. Sixlabors.com, you've probably heard of them because you've heard of Image Sharp, one of the great 2D graphics libraries, open source with a great license, and you've got manipulation of graphics and drawing, as well as ASP.NET Core manipulation middleware. Good product that's used by a lot of folks. Very, very cool stuff. And then also, as I get to the end here, we turn back to Jamie and get ready for our party. I want to just remind you that if you go to the .NET website, you click on Learn, we've got books, we've got architectural guides, we've got PDFs, we've got videos galore. We want to make sure that you can find a happy face of somebody who seems friendly to you, who's going to teach you how to use .NET in cool places like Unity, like on a Mac, in machine learning, in places that you wouldn't necessarily expect, like Apache Spark. We've got F#, we've got C#, we're having all kinds of fun. And
ever .NET 6. I'm very excited to use .NET for IoT. So it's underpinned supporting the Windows IoT platform and Linux devices as well, having some things like accelerometers, gas sensors, liquid sensors, all kinds of things. And if we click on one of these, so this is just an example, is a Sense hat. And I actually have a Sense hat here. So a Sense hat is an add-on for a Raspberry Pi, and it's called a hat because it's hardware on top, so you connect it on top. But they have the library to make it easy to work with. All you have to do is do new Sense hat, and then you can interact with things on the Sense hat. So it's quite tiny, but there's a little joystick, this thing at the top. And so the code that we're looking at here, just state, is controlling the joystick on this device. So it's fun. It makes it easy to play with. There's a ton of examples already that the community has set up, and all these different devices that you can get started working with on an application. Well, in more of a maker board, like one of these Raspberry Pis, it only takes a few commands to get it working. On the top, we have the framework dependent, first installing the .NET on the device, and then copying the files over and running it. In the self-contained, it's about publishing with all of the dependencies and compiled versions, copying it over and running it that way. So it's pretty easy to get started for these simple applications on these microprocessors. And when it comes to debugging, we can use our similar kind of tools that we use, the Visual Studio Code. You do have to set up the launch settings to be communicating to your device, set up SSH onto the device, and you can debug from within Visual Studio Code. So I have on that Raspberry Pi I just showed you, I have an application set up. So it's the Hello World to Blink light. I just realized I don't actually have the light connected, but the application is deployed onto the Raspberry Pi. So I'll still be able to debug it and see what happens. So all you can do is, so in here, I've set up my launch settings I deployed it as a self-contained application. And then I'm going to use PuTTY to just remote SSH onto the Raspberry Pi itself. And the files have already been copied over. So all you have to do is either click F5, or you can go in here and do Start Debugging, and it'll launch and debug directly on the device. So it's hit the breakpoint. If you have more of an advanced app, you can actually debug what's going on with your IoT application, which is really cool. Because I don't have a light set up, it doesn't it doesn't fully work. So I'm just going to stop that because I just wanted to show you how you could do it. Cool. So if we're not working with microprocessors, so we don't have a full powerful device like the Raspberry Pi, but we want to work with microcontrollers, there's also the .NET Nano Framework. So the .NET Nano Framework is a free open source platform that enables the writing of managed code applications to constrained embedded devices. So it's a community-led implementation of .NET for those very, very small processors. So think of something that has, low CPU and memory, microcontrollers, low battery, that kind of stuff. That's where the Nano Framework can really come into use. And you can use this for full big-scale industrial solutions or even just your home automation system. It can be useful if you're, have low connectivity out on a farm, or some of these agriculture examples that Brian was just talking about. So the Nano framework is really just a tuned down version of the .NET runtime. So it's called Nano because they took the core parts of .NET and optimized it for those microcontrollers. So it's a reduced version of the .NET CLR and base class libraries, and it does have the most common APIs, including some of the .NET IoT. So it uses that same language of .NET, same tooling, same compiling tool chain, but all gets simplified into smaller code to run on those small devices. And the good news is it's all open source, so you can go contribute to it there if you like as well. They also have support for a long list of boards themselves. Creating a new project in my Visual Studio, and if you have the extension, you can just search for Nano, and it'll come up with the base templates. So if I create one of those, I'll just use the default name. Hopefully it creates quickly, but if it creates, we'll see that there's NuGet packages. It looks like your standard .NET application, so it's the code that we're all familiar with, and it makes it even easier for .NET developers to get up and running. Cool, so it just created a very basic hello world. But yeah, there's information on their GitHub. They have their own set of NuGet packages, their own set of the Android SDK that's all been slimmed down to work very nicely with Nano Framework on those microcontrollers. .NET versus Nano Framework, the things you want to look at is what type of device you're using in your different scenarios. So .NET IoT is the full .NET Core libraries, but it's targeted for more powerful boards. Nano Framework, more of that low-level microcontrollers. And they both have their pros and cons, all open source, so you can go see what is best for your needs, but a lot of it comes down to what kind of device you are using. So we already talked just before my session here is really focused on more of that, so enterprise IoT, looking at full .NET on embedded microcontrollers, has this great plug-and-play IoT library focused on security, and it's cloud agnostic. So if you do want to integrate with some of the other clouds, you can do that as well. And we saw some of the code that they started with, but in terms of just more of a simple Hello World Blinky Light application, all you have to do is new Meadow app, and you go and send your device pins, and it's good to go. You have your Meadow application there. They have all their different packages for you to use with their hardware. In terms of looking at integrating with Azure and the whole Azure IoT services, we have the SDKs that are available for .NET. So there's, within the Azure IoT SDK suite specifically, there's SDKs to connect to client devices using the Azure Iot Hub, and SDKs to manage those service instance from the backend .NET app, provisioning devices, managing those provision services, and tons more SDKs within the general Azure SDKs written in .NET. So this makes it really easy to use Azure services from within your .NET applications. And some of these are examples of this. We mentioned Azure Iot Hub. So Azure Iot Hub provides a cloud-based solution backend to connect any device virtually. So really allows you to extend your solution from the cloud to the edge per device authentication, built-in device management, and scaled provisioning. And this can be managed through your .NET applications with Azure SDKs. In the bottom left corner, we have a short code example of how you can create a device client, connect it to your hub, and send that telemetry onwards for further processing. Then you can go into your, it'll send it to like your IoT Explorer, where you can have a graphical tool to interact with the devices connected to your hub. So the Azure IoT features integrate really nicely with our .NET IoT applications. For further ships between our different IoT devices, and you can have a really development-based approach of creating and interacting with your digital twins, which are a full blend to things like time series insights and all of that. So you can make really powerful IoT solutions with .NET. And as mentioned at the start with the IoT signals report, we found that AI and machine learning are essential to those advanced IoT strategies. So actioning these insights and creating valuable information from the data coming from your IoT devices will provide these improved business outcomes. And the good news is that you can use .NET for your AI and ML technologies in your IoT solutions. We have ML.NET, which is a machine learning framework, all based on .NET. And just like the other things we looked at today, it's free, it's open source, cross-platform, and it allows you to train, build, and ship custom machine learning models using .NET. And there's a session in the conference based on ML.NET as well, so I'd recommend you checking that one out too. You can also go into robust libraries such as the Azure Cognitive Services, which allow you to add cognitive capabilities to your applications that can then be integrated into your .NET IoT solutions using the .NET SDKs. So they allow you to have things like image recognition, language processing, and much, much more. Think about you're a fruit grower and you have a harvesting machine that automatically picks all the fruit from the trees. You can have some visual analytics to tell it whether it's good fruit or bad fruit, and have some automatic sorting going on in your IoT solution powered by .NET. If we also want to look at some other packages, the video analyzer is a really cool one. It's still in preview. So you can get started today with .NET IoT by just going to the Learn IoT website to find all of the different resources there. Thank you very much for joining. I hope you enjoy our bit quick tour of the world of .NET Internet of Things.